So using MPLS traffic engineering, we can manipulate the routes per the requirement. Here what we are doing in this lab is we have traffic engineering, and we got two paths. We want to make use of both the paths when the requirement comes. When there is a traffic from customer A comes, I want to put them in one path, meaning here via router 3, 4, 5, and 7. And when customer B comes, I want to put those traffic in the path via router 3, 6, and 7. Okay, so that's the aim. We are traveling on this for this is the second day. We already have the IP addresses on place everywhere except the VRF related configuration. All the rest of the configurations are over. If you check in R2 show IP protocol, even here also the protocol OSPF is running. Protocol OSPF is running. So what we have is we have OSPF on router 1 and router 2. Which means I'm going to run two more OSPF here. I already have one OSPF for the internal. Let me show you that. Router 3 show IP OSPF interface brief. I have OSPF called 10, which is running on serial 6/0 and serial 6/1. So I'm going to have two more OSPF. One for customer A, another for customer B. Before that, I want to create VRFs for this customer. I don't have VRF. Show IP VRF. I don't have any VRF. Okay, what else I have? I have OSPF reachability from here. Ping 777 with the source 333. What else I have? I have MPLS. goes to router 6. This is router 6. 3.1.2 is router 6. It goes to router 6 and goes to router. This is 4.1. Let me put it here, 4. 4.1. And on this side, it is 4.2. Okay. So we don't have MPLS. Even if you have MPLS, it won't show because it's just one hop. Let me see whether I have MPLS or not. What's the command to verify? Show MPLS interfaces. No MPLS. So no MPLS, but we have BGP. I'll show you. Show IPv4. Show BGP IPv4 VPN. Oh, no need to be IPv4. VPN v4 unicast local server. You see, we got BGP VPN MPBGP. We got VPN, but we don't have MPLS. We don't have VRF. We don't have routing between C and P. After this only we can go for traffic engineering. So a lot of things are missing, right? Router 8 and router 9 also runs OSPF. Show IP protocol. See, there's OSPF. And on router 9 also I have show IP OSPF. Show IP protocol, if we type it, BC. Okay, so one more thing which I forgot to tell is I have set 2 meg bandwidth on all the link. 2 meg, 2 meg only. I have set 2 meg bandwidth on all these links that I'll show you now. I'll just randomly pick one link and then show you. But that is what I have configured on every link. Let me show you on R7 or or R5. R5. There are various ways I can show you that, but let me take you to the easy way where I configured. Show run interface serial 6/0. You will find there 2 meg, 2000 kilobits. 2 meg. This I have done on every interface. You see. Let me also show you on router 6 one more time. One more router. Show interface serial 6/0. When here you will see bandwidth on the link is 2 meg or 2000 kilobits. Fine. This is done on all the link. That's why I have also written it here. 2 meg, 2 meg, 2 meg, 2 meg. So according to the bandwidth, the best path, the calculated best path, should be via router 6, P3. For router 3 to reach router 7, the best path will be always via P3, 2 meg and 2 meg. Whereas here, 2, 2, 2. Yeah. So let's go to router 3 and check. Show IP route OSPF. You can see that the OSPF costs, and you can also see for for uh, for reaching 777, this is the cost, and it is via router 6. This is the IP address of router 6. You see 15.3.1, and the other side will be 15.3.2. The reason why I put 3 is it's talking to provider 3. Here I put 15.1. The reason is it's talking to provider 1. So you might have guessed what should be here. It should be 15.2. That's the IP address that you will find on router 5 serial 6/0. Router 5 6/0. You see 15.2.1.2, and this is 3, this is 4. What should be this one? You see 5.1. Just this interface. And this 7 will be 5.2. So we understood what IP address is configured where and why. Now we need to fill the back gaps, all those things that we have not configured. On router 3, we need to create VRFs. IP VRF cust_a. Route distinguisher. We can give any number. I'm just going to use a number. Let's say 65 colon. The reason why I'm using 65 colon 1 is the document that I shared with you in the previous class has got this. So I'm just matching with that so that when you do, you will be comfortable. Next. Route target for both import and export, I would like to give 65 colon 1 for customer A. For customer B, I'll give 65 colon 2. All right. Next. If you focus here, I have show IP interface brief. I have only one interface called Lubeck 10. Lubeck 10 is only one interface. I just got only one interface, Lubeck 10. But I would like to have another Lubeck interface, Lubeck 100, and put an IP address 100.100.100.100, right? Likewise, I want to have another Lubeck called 200 and give an IP address. The reason why I'm doing this is I want this to be the address of the destination when I configure for this VRFs. All right, so when I configure 1 minute, route. So we'll be using this address and we'll use this as the next hop, the tunnel next hop, the tunnel's next hop. That's why we are doing this. You will come to know when I put it under the VRF. So I'm going to have another interface called loopback 200, and the IP address there I want to give is 50. IP address is 50.50.50.50, 255.255.255.255. So this will be the BGP next hop for customer B. BGP's next hop. Now, how do we achieve this? We need to put it under the VRF first. We created 2 VRFs, right? So I go to, did I create 2 VRF? No, I created 1 VRF. So I'll go yeah, IPv,
only one.
Yeah, so far only one. But I got the interface loopback for both created. Now I'm going to say BGP next hop for customer A is loopback 100 interface. See, what is this going to say is this is going to advertise as an attribute to BGP saying, I'm your next hop. I am 100 or 100 or 100 or 100 is the next hop. All right, so you'll understand this better when we finish. IPVRF cust underscore B. As I said, I'm going to use same 65 but colon 2 for customer. There we give colon 1. Similarly for route target 65 colon 2. And then BGP next hop is loopback 200, which has got 50 address. Right, so we got 2 VRFs. Show run section IPVRF. Now let us configure the similar VRFs with small change on router 7. Okay, let me go to router 7 and finish this, then we'll come back to router 3. When I configured, I did not say import or export. I simply said route target 65:2. When I don't say import or export, which means it is for both. Got it?
Yes.
Okay. So this is what we have in router 3. Bad. As VRF. Now on router 7, similar configuration. Even here we need two loopback interface. So let me first create loopback interface. Interface loopback 100. IP address. There we gave 100, 100, 100, 100. Here I'm going to say 200, 200, 200, 200. So this will be the next hop for that BGP 100, 100, 100, 100 from there. This is loopback 100. We also going to have interface loopback. What is the interface name we use there? Or let me use, there 50, 50, 50, 50. I said 60. IP address will be 60, 60, 60, 60. 255, 255. So this will be the next hop for customer. BGP next hop for customer B. All right. We already have 7777 as a loopback. That's there already. Okay, next. I'm going to say the route target. The route target should be the same. Whatever their import here, it should be export. Whatever their export here, it should be import. And these numbers can be same, can be different. That doesn't matter. It's locally significant. So I don't think there's any need of change. Say, and the write to memory. Enable config T. That's all. I'm going to paste this on router 7. So router 7 is also having two VRFs. So we got the VRF ready. Yeah, the loopback interfaces are there. I want to show you one more loopback interface that we have. Show IP interface brief. I was pinging earlier loopback 0, which is 7777. Now recently we have added this too. Oh, I made a mistake. What is that? This should be 60. In our case, in this router, it should be 60. And this should be, this is okay, 100. I say 200, but I have given IP address to 100. So that is okay. No interface loopback 200 because we don't have IP address. I have assigned 200. But this one under the VRF do show run section router, sorry, section IP VRF. This next hop here should be 60. BGP is next hop. See, we are very clearly saying under VRF that this is going to be a next hop for BGP. Loopback 60. Okay. Now let's verify show run section IPVRF. All right. Now, we got router 3, we got router 7 with VRFs configured. What needs to be done is we need to allocate some interface to the VRFs. So I would like to go to router 7 itself. First, let's finish router 7. In router 7 interface F00, I need to put it under the VRF called custom A. IPVRF forwarding cust_A. And this interface needs an IP address. Let me show what IP address I've given on router 8. On router 8, if you see here, show IP interface brief, on F00, I have given 10.250.81. And the mask is /30. See, show run interface F0/0. Mask is 30. I need to simply use the same, but only the host ID will be .2. The host will be .2. So the subnet matches with the neighbor. What else we need to do here? We need to run routing protocol. You remember we already have a routing protocol OSPF 10, isn't it? For ISP we have given OSPF 10. But for a customer, I'm going to say customer 1 is OSPF 1, customer 2 is OSPF 2. Customer 1 is OSPF 1 and customer 2 is OSPF 2. It will be nice. I don't know why in document I have said customer 100, customer A is 100. No need. Make it as 1.
And which IP is 10.250.80.2?
What? See, on F00,
That IP.
on F00, I have said .2 because on here 80.1. Here it is 80.1. I showed you. See, 80.1 and router 1. Sorry, router 8 customer. 80.1 is on customer. So 80.2 should be on the other end because it's /30. What happened, Ko?
Yeah, I see it.
All right. All right. So what I'm going to do is I'm going to run IP OSPF 1 area 0. So under this VRF, there is one OSPF already running now. And what is the process ID? 1. You see, the neighbor is formed. With a customer, the neighbor is established. Likewise, I'll go under interface F0/1 and say you belong to IPVRF forwarding customer_B. No shutdown, IP address. The IP address should be the IP address, the same subnet matching the other side. Other side, I remember I gave 90 in the third octet. 10.250.90. Let me show you that. Router 9. Router 9. Show IP interface brief. You can see here 90. Now I need to just give .2. .2. The mask is 32. Sorry, 30. And IP OSPF2 area 0. I'm running OSPF. Now you'll see neighbor forming. So CEP relationship is done in this side. Let us check the routing tables now. Show IP VRF cust underscore A. Show IP route VRF cust underscore A. And you can see that these three subnets are coming from customer A. These are the three loopbacks of customer A. We have put three loopbacks there. I can show you. It's a three loopbacks. From route 8, we are learning this on router 7's routing table. Likewise, I should see on B. There 80, here it is 90. This is the difference. All right, so similar job, we have to do it on router 3. Router 3 also runs 2 OSPF. Oh, sorry, 3 OSPF. One is already running called OSPF 10. And now we need to run OSPF 1 and 2. Router 3. I'm just trying to match with this document that we already have. Okay. Go to router 3. Interface F00. Bring it up. IPVRF. You belong to cust underscore A. And the IP address on this interface will be, we need to go and check on R1. R1, what I have given. Show, I think I have given this 10.250.10.1. Show, anyway, we'll verify. Show run interface F0. This is what. So on router 3, in this interface here, I need to simply put 2. I put wrong command. On interface, it is IPVRF forwarding customer forward. Now you put the IP address, will accept. Okay. And I'm going to run OSPF IP OSPF 1 area 0. You'll see neighbor coming now. Okay. Likewise, I go under the other customer's interface and I say, hey, this belong to VRF B. No shit. And IP address, I need to check what I given on router 2. I see I have given this number, the subnet. Anyway, I want to check it under the running configuration. Show run interface F00. Yeah, this is what we have given. And I need to simply change the host portion on router 3 to 2. IP OSPF 2, this is another OSPF area 0. Now, if you see, there are 3 OSPF in this router. I can show you that. Show run section router OSPF. You see, OSPF 1 is for VRF A, OSPF 2 is for VRF B, customer B, OSPF 10 is local with this route right. The other loopback interfaces that we have created is for this and this to act as the next hop in BGP. Okay. What else? The customers need to give the route to the VPN. You see, show IP route VRF cust underscore A. You have learned these three routes from the customer. And you have also learned these three routes from the customer. But this need to be placed inside the VPN so that router 7 VRFs will also learn this. Likewise, in router 7 also we have some learned routes from the customer. If that needs to come, it needs to be placed inside the VPN. What is VPN made up of? VPN is made up of BGP. So I need to do redistribution. I have to do redistribution between BGP and the customer OSPF and vice versa. Yes. So that needs to be done. Let us do that. On R3, I want to place these routes into the BGP VPN. So I go under address BGP, router BGP. I gave 65,000 as the autonomous system number. And now I have to go and say address family VPN v4, which we already did. Actually, we have already done this. We have done this. Otherwise, you won't see VPN. Early in the beginning, I showed you the VPN output. Let me show you one more time. Do show BGP VPN v4 unicast all summary. You see, VPN is already up with router 7, which means I was here earlier in this mode, address family VPN v4 mode. I have already activated the neighbor. If you want, I can show you in one more place. Do show run section router BGP. Look at this. You already have this activation. This command will come automatically. I did not type. It will come automatically. This is what carrying those route targets and next stop informations. Okay, fine. Now, what I should add to this is the redistribution part, but not here. VPN is already there. I need to just give it to VRF and it will be taken into VPN. So I say address family IPv4 VRF cust underscore A. I have a customer like this, and sorry, I have a control plane like this for customer A. We created this called VRF. Inside that, I'm saying redistribute OSPF 1, which is in VRF cust A. Done. Likewise, I need to go under another VRF address family VRF customer B, redistribute OSPF B. That's it. What am I doing? Sorry, something is wrong. Must specified does not match existing router. Oh yeah, because it's OSPF2. For customer B, it is OSPF2. Now it will match. OSPF2 is what we created for VRF2, VRFB. Should remember that. Okay, what is next? Now I should be seeing the routes on router 7's VPN. Let's check. I can see. I can see something because we did not enable MPLS. So it says invalid MPLS label. It's okay. I'll come to this one, but I just simply want to check. Show BGP VPN v4 unicast all. See, there's no room because we don't have MPLS. So R7 is receiving something from R3, means that those are the prefixes of the customer, but there is no label. That's the problem. Okay, we need to enable MPLS on all the devices. Let's enable MPLS on all the devices. On R7, I'll say config T MPLS IP, and I would like to give a range MPLS label range. See, for router 7, I'm going to say 700 to 799, so that we will know who is giving what label. Okay, and then I'll go under interface serial 6/0 MPLS IP, interface serial 6/1 MPLS IP. Okay, so let's now go to router 5. MPLS IP, MPLS label range. This is router 5, so I'm going to say 500 to 599. Interface serial 6/0 MPLS IP, interface serial 6/1 MPLS IP. Alright, I'm going to copy this to a notepad and do some small changes and paste it on the rest of the routers. Right, for router 4, this is going to be 4 here, this is going to be 4 here. Router 4, let's go to 4. Done. And for router 6, this is going to be 6 here, this is going to be 6 here. Router 6. And for router 3, this is 3 and 3. Okay. So we got the MPLS. We have also redistributed the routes under BGP from OSPF in the left. Still, we have not redistributed from the OSPF in the right to BGP. We have not done the redistribution. Now let's check whether we are able to see. It should come. It should come. Okay, meanwhile, what we'll do is we'll do the redistribution part from router 8 and router 9. We are learning the routes. Show IP route VRF. We are learning this route. This we need to give it to BGP. Router BGP, it is 6500,000. Address family IPv4 VRF cust_b. Redistribute OSPF 2, which is for VRF cust_b. And likewise, we have A, address family. And now we are going to redistribute OSPF 1 and A. So one way redistribution is over. What is one way? OSPF to BGP is given, but BGP to OSPF is not yet given. Yeah, so that part is not yet done. BGP to OSPF we have to do. So how to do that? Router OSPF 1, which we created for VRF cust A, and I say redistribute BGP 65,000, including the subnets. That easy it is. Likewise, I need to go under router OSPF2 VRF cust_b, redistribute BGP 65,000 subnets. Yeah, so those things will take care of the distribution of routes from OSPF to BGP and BGP to OSPF. Okay, so we have done this on one side. Let us do it on the other side also. Router 3. On router 3, I'm going to say router OSPF 1 VRF cust_a. 1 minute, I want to verify. Did I give OSPF to good? A. Redistribute BGP 65,000 and including the subnet. Likewise, I go to B. B is 2 and redistribute with subnets. Done. So two-way redistribution is done. First we did from OSPF to BGP. Now we have done from BGP to OSPF. And what else? Show IP BGP summary. Do I have neighbor? Yes, I have neighbor. VPN is also there. Show BGP VPN v4 unicast whole summary. We have this, but I'm not learning any routes. I'm not learning any routes, so there should be some issue. Here is this. We have the routes. Here we got the route, but this is not a route which we learned from the remote. This is coming from your own customer. So there is nothing learned so far. These are all coming from router 1 and router 2. We have placed these routes into VPN. We have placed these routes into VPN, but VPN is not taking it. You know why? Because the next hop we have said is 100, 100, 100, 50, 50, 50, which is not reachable from router 7. We are going to do through the tunnel. First, we need to bring the tunnel. So, it's going to be bigger now. We need to bring the tunnel. Only via the tunnel, these routes should be distributed, not via normal VPN. I want one tunnel to go via this way, through which customer A route should be advertised. I want another tunnel to be via this way, the underway, 3, 6, and 7. And these routes should go via that VPN. For that, we need tunnel, and we need to point out the next stop by writing the static route pointing towards the tunnel, which is again a big process. So we are not going to do that today. We are going to do part by part. Till today, what we have done is we got all CP up, and we are learning the routes inside the VRF routing table. And we have also said take these routes and put it into BGP, and take the route from BGP and give it to OSPF. We have done that part. Only one main important piece is missing, which is tunnel. Yeah, MPLS is also running. If you go and see in router 3, show MPLS forwarding table, you can see the labels. See, these are coming through VPN. I told you VPN is up. But why I'm not learning routes? Because you don't have tunnel. Because the next hop is unreachable. We do learn these routes. You see, in MPLS, it shows the route. But in BGP table, there is no route. If the MPLS shows the route, which means the routing table also has got the route. You see, show IP route for VRF cust underscore A. Wait. Now, this is advertised to the VPN. Advertised to the VPN, not learned. Okay. Now.
Hello, Jay.
Yes.
Hello.
Yes.
Is it mandatory to use tunnel to have that advertised route?
Repeat again.
Is it mandatory to have a tunnel so that we can learn that route on BGP?
See, if you don't have traffic engineering, then there is no need of tunnel. Without traffic engineering, you will not have that next hop command which we gave under VRF. Only for the sake of tunnel, we have that next hop. Because you have put that as the next hop, that next hop is unreachable. See, router 3 says, router 3, show run section IP VRF. If you see, you have given a next hop here as loopback 100, which is 100, 100, 100, 100. Is this pingable from router 7? Ping. 100, 100, 100, 100. No way. There is no route via any VRF or normal routing table. There is no route to reach. It's supposed to go via VRF A. For that, you need to write a static route because this address is unreachable. Show IP route VRF just underscore. So there is no route to reach 100 anywhere, neither in global routing table nor in VRF. So the last piece is forming the tunnel. And now after we form the tunnel, when I write the static route, it will make sense for you why the static route and how the static route works and why we are not learning the route and all those things. Only one piece is missing, which we'll see in our next